Hello, good morning, good afternoon, or good night. So for this lecture, I will teach you on how to handle missing data. So what are the reasons why we need to handle missing data? So first, explanation. Real world data most of the time is not complete. Another one. So real world, not word. So real world data often has a lot of missing values. That's for sure. So the causes of missing values can be one is data corruption, or another one is failure to record the data itself. Handling missing data is very important, specifically during the pre-processing of data. More on this on the next sections. Some machine learning algorithms do not support missing values. So it is important to know how to handle missing data. So these are just some of the reasons and explanation on why handling missing data is very much important. Okay, so let's continue. So for the sample dataset, so let's create a synthetic dataset. It's not true dataset, just for lecture purposes. So let's create a dictionary into a data frame. So I have here the values already. So I will just copy paste this one. So copy paste. So we're creating a dictionary with key of A, B, C, and D with a specific value of list. So np.none is a constant, part of np, the numpy library, which means not a number. So let's create a data frame out of this. So data frame is equivalent to pd data frame of d. So alt enter. So let's take a look at our data frame. So this is our data frame. So as you can see, at row 0, we have one missing value. At row 1, we have one missing value. At row 2, there's no missing value. At row 3, index 3, I mean, this is row 4. So this have a 2, not a number value. In terms of column A, 1 missing. Column B, 1 missing. Column C, 2 missing values. In terms of column D, the data is complete. Okay, so my practice here is to check for missing values. I usually do this first. For the check for missing data, so I use the df is null function. So if I execute this one, so these are the tables, as you can see. So nan is equivalent to true. So the missing values are equivalent to true. But if you take the sum of this one, so you will have a summary of missing values. So for example, just like this one. So A has 1, so B has 1, C has 2 missing values, so D has none. So I recommend doing this one for your specific data sets. Use the is null and the sum functions. Okay, So let us continue for our first strategy. So let me comment this one, is to drop rows. So we will use the df dot drop na. So if you do this one, so all with a rows and columns with missing values, which is denoted by NaN in our example. So let me show you the data frame again. So all will be dropped except for this one, because this one has a complete set of data. So if you do not specify an axis, it will drop rows. If you want to specify an axis, for example, axis is equivalent to 1. So axis 0 is row, axis 1 is column. Executing this one, it will drop columns A, B, and C. Why? Because we have missing values. So NaN, ANA, NaN, and NaN. So the D will remain. Again, this is not a permanent. It's not permanent. Just so you, it is just showing you that it is dropping in terms of column, that this one is dropping in terms of row. Okay, so I hope that is clear. So we can also drop with a specific threshold. So drop with threshold. So remember, this counts not A and N values. So this one counts the not NA in values. So remember that. So df dot drop NA. So we specify the thresh of 1. So no values are removed. Why? In terms of row, because our threshold is, remember, is 1. If you have a 1 with none, not A and N values, you're not being dropped. But if I have 3 now, so the last index, which is 3, will be dropped. Why? Because I have 2 not N values anymore. So the remaining one has 3. So 5, 15, and 10, that's 3. That's the threshold. So 25 and 20, that's 3 also. That's the threshold. 30, 10, and 40, yes, that's the threshold. But 40 and 80 is 2. It does not meet the threshold of 3. That's why that it will be dropped. So if I have a threshold here of 4, so the index 2 will remain, because this one has a complete set of data. So let's bring this back to 3. So I hope this is clear. So remember, this counts not NaN values. Also, you can do a drop NA with a threshold in terms of column. So let me copy this one. So in terms of column, you also provide a specific axis. So we are drop with a threshold here. Specific axis, which is will be dropping specific column. So threshold axis is equivalent to 1. So we're dropping here a specific column. As you can see, we drop the C. Why? Because this has 2 NaN and 2 not NaN values. So that's why the C column is dropped. So for our second strategy, so of course this is the recommended strategy. So we fill in a missing values using mean of a column. Usually you use mean, and usually you use this in terms of a column. So of course, so we use this one. So data frame of A, so remember, you can index a data frame in terms of column, terms of name. So data frame of A, so you use the fill in A function, then you fill in a specific value. So for example, df A dot mean. So this means that you are filling the average value in terms of A. So you average 20, 30, and 40. So our NaN will be 30. But again, this is not permanent. As you can see, it's still A and N. So what you can do is to copy this one and reassign it to df of A. It's equivalent to this one. So we're assigning a specific filler, which is the mean of the value of A, to data frame of A again. So if I execute this one and check our df once again, so we already fill in this specific value. So look at this one. So from A and N to 30. So you can also do this one in terms of I don't know if you so why you're using a median, but of course this one is possible. So for example, so we're using here a median, but this time let us change to column C. So alt enter, so df. So as you can see, the column C, 15, 30, 45, and 30. So the 30 is filled in. Low. So you can also do, which is more common, which is you fill in using a mode. So we use here the mean, we use here the median, and now we're using the mode. But again, the NumPy or the native Python does not support the mode. But if I will import the statistics module, so you use this one. So import statistics. So we're using the statistics module. So we can use the mode. Also, SciPy has also the mode. But this time I will use the statistics. So copy this one. So instead of using this one, so we use the statistics module. So let us replace data frame, which is series of B. So we use statistics dot mode. Mode of what? So the data frame of B. So df. So as you can see, mode is the frequent value. So A and N. Why is it hard to pronounce? Will be replaced by the frequent value, which is 5. So these are some of the strategies of filling in and handling and missing data. You drop rows or columns. So to review, in order to handle missing data, you resolve to dropping rows or columns. Usually you drop rows, not columns. Also, you fill in missing data. Specifically, you use the mean or you use the mode to fill in specific data. So you use the mode, but again, you use the statistics module because Python do not have a native mode function. So for the next lecture, we will be discussing about group by in Python. So thank you very much.